Geometry. Review chapter 19, which is finding perimeters and areas of various shapes. Determine the perimeter of the following figures. Lines that appear to be perpendicular are, and lines that appear to be parallel are. So to find the perimeter, we're going to add up the lengths of all the sides. So we have a side that's 7. We have a side that's 2, and we have 1, 2, 3, 4, 5, 6 of those. So we have 6 that are 2 in length. And then if this is 2 and this is 2, and this whole length is 7, that means that there's 3 left for this side here. So that's going to be 22 centimeters. Number 2, to find the perimeter, we add up the lengths of all the sides. We have an 11 and a 12 and a 9 and 1, 2, 3 4s. And we have 2 7s. So we got a 7 and a 7, 3 4s, a 9, a 12, and an 11. That adds up to 58 centimeters. Number 3, we're going to have to find this arc length around the circle, and then we have to add these 2 radii to it. So the perimeter of Pac-Man is going to be theta over 360 times 2 pi r, and then we're going to add to that 2 of the radius. So that central angle, if we've used 90 here, that means we're left with 270. The radius is 4. $270 divided by 360 reduces to 3/4. I'm just going to leave the 4 here for now. I'll show you why in a second. Because I can then say, well, 4 divided by 4 goes 1 time. And I'm left with 6 pi plus 8. And this is centimeters. It's a linear unit because we're finding perimeter. Number 4, determine the area of the following figures. Lines that appear to be perpendicular and parallel are yada, yada, yada. To find the area of a parallelogram, the base times the height. The base and height are perpendicular. Base is 20, height is 8. It's going to be 160. The units is square centimeters. Number 5, to find the area of this figure, it's quite the complicated figure. We're going to have this rectangle here. Call that rectangle 1. Rectangle 2. Rectangle 3, and rectangle 4. Rectangle 1 has dimensions of 6.5 and 3 because this is 3 and it's 1 dash, so this is 3. So I guess I should write first base times height plus base height times height 2 plus base 3 times height 3 plus base 4 times height 4. So that first one is 3 by 6.5. The second one is also 3. And then if we've used 3 here, and this whole thing is 6.5, that means there's 3.5 left for this. So that's 3 times 3.5. 3 plus 3 more, that makes this 6. This whole thing's 6.5, so this part right here is 0.5. And its base is also 3. 3 times 0.5. Last one, we have 3 times 6.5. It's the same as that first one. So that's going to be 19.5 plus 10.5 plus 1.5 plus 19.5. That adds up to a grand total of 51, and the units here are square centimeters. Number 6, got to find the area. We need the base times the height. That's how to find the area of a parallelogram. Base and height are perpendicular. If we use this base, we got to use this height. We don't know what that height is. Fortunately, if this side is 5 square roots of 2, this side is 5 square roots of 2. It's a special right triangle, this little devil. The hypotenuse is 5 square roots of 2. That's the short leg times the square root of 2. That makes the short leg 5. Each of these are 5. So the height is 5. 16 times 5 is 80. The units is centimeters. So the area of the parallelogram is 80 square centimeters. Number 7. To find the area of this rectangle, it's the base times the height. We don't know either. What we do know is that if all these sides are the same length, and the direction said things that appear to be perpendicular are, these are 90-degree angles, the diagonal of a square, like any rhombus, bisects the opposite angles. So these both have to be 45 because 90 cut in half is 45. That's a 45, 45, 90. The hypotenuse is 5 square roots of 2, so the leg, the short leg, has to be 5. So the base and the height are both 5, so the area is 25 square centimeters. Special right triangles are not going to go away, kids. Number 8, area of a triangle is 1/2 the base times the height. Base and height are perpendicular. So that's half of 8 times 5. That's 4 times 5. That's 20. The unis are square centimeters. Number 9, it's a right triangle. Area of the triangle is 1/2 base times height. Base and height are perpendicular. So we could use a base of 15 and this height right here. We don't know what it is, but we do know it's a right triangle. In fact, it's a Pythagorean triple. It's an 8, 15, 17. If you don't recognize that, no big whoop. Use the Pythagorean theorem and you'll find that that missing side is plus or minus 8. We only deal with positive lengths at this point in our young academic careers. So it's 1/2 of 15 times 8, which is 4 times 15. That's 60 square centimeters. Number 10. Wow, these special right triangles just refuse to go away. To find the area of a triangle, it's 1/2 the base times the height. So we're going to use this base of 9 and this perpendicular height right here. And the perpendicular height that I pointed to, we don't know what it is. But we do have this 45, 45, 90. And the hypotenuse is 5 square roots of 2. It's going to make the leg 5 because the hypotenuse is the leg times the square root of 2. So that's 9 times 5, which is 45 over 2. I'll just leave it like that. Square centimeters. Number 11 is an equilateral triangle. All the sides are the same length. That means it's also equal angular. Each angle is 60. If I draw the height, it's going to cut that in half. That meaning the angle and the side, and it forms a perpendicular. Area of a triangle, 1/2 base times height. The base is 10 because all the sides are 10. Well, what is the height? Well, we once again have a special right triangle. Special right triangles don't go away, children. Side opposite 30 is 5 because the side got cut in half. That's the short leg. The long leg is the short leg times the square root of 3. So that makes this 5 square roots of 3 is the height. Half of 10 is 5. 5 times 5 is 25. So the area is 25 square roots of 3 square centimeters. Number 12. We want to find the area of this figure. I'm going to break it down into the area of a rectangle plus the area of a triangle. This rectangle has dimensions 4 by 4, which is 16. The triangle, which is 1/2 the base times the height. I'm assuming the base and height are different, so using different subscript variables. Let's see. Well, the height is clearly 4. So this is the height. This base from here to here, this whole thing's 11. Part of it's 4. It means the other part's got to be 7. So the base is 7. Half of 4 is 2. 2 times 7 is 14. That's going to make this 30 square centimeters is the area of this figure. 13. More practice. We need more practice. This is a trapezoid. To find the area of a trapezoid, it's half the sum of the bases times the height. So currently, we only know one of the bases, and we don't know the height. This is a special right triangle, 45, 45, 90. Hypotenuse is 6 square roots of 2. That makes the short leg 6. That's also the height. These two triangles are congruent by the, let's see, why are they congruent? Well, let me tell you why they're congruent. This is 11 then here, and then we are told this is 6 square roots of 2. And then logically we can conclude that these are also 6 for the same reason, which then makes this whole length 6 and 6 and 11, which is 23. Alrighty, so the area of the trapezoid is the sum of the bases, 11 and 23, times the height of 6. 11 and 23 is 34. Half of 6 is 3. 3 times 34 is 102. And we're using square centimeters. Lovely. Number 14. We don't know the height of this trapezoid. Check this out. If I drop this down on both sides, this is clearly 12 because it's 12 up here and the bases are parallel. Leaves me 10 centimeters left. Since this is an isosceles trapezoid, it's isosceles because these legs are the same length. These are going to be the same down here. So the whole thing's 22. We use 12. And then for these spots, we got 10 left divided equally. That makes each of these 5. This right triangle, we can find the height with the Pythagorean theorem, or we can recognize that it's a Pythagorean triple. It's a 5, 12, 13 Pythagorean triple. So to find the area of this trapezoid, which is 1/2 the sum of the bases times the height. The bases are 12 and 22. The height is 12. I'm going to multiply this right now, the 1/2 times the 12, and get 6. 22 and 12 is 34. 6 times 34 is 204 square centimeters. 15. Determine the area of the circle or the shaded sector. Well, to find the area of a circle, it's pi r squared, where the radius is 9. That's 81 pi square centimeters. 16. The directions were to find the area. We can't find the area unless we know what the radius is. So if we use the formula, circumference is 2 times pi times r. And we know the circumference is 14 pi. We divide both sides by 2 pi. We're going to get the radius is 7. Once you know the radius is 7, we can find the area. It's pi r squared. We're going to find the area is 49 pi. We weren't given any units, so we just generically call it square units. Number 17 is a sector, shaded part. Find the area of a sector. We're going to take a central angle divided by 360 times the area of the complete circle. So the sector has a central angle of 300 degrees. The radius is clearly 12. 300 over 360, that reduces to 5/6. You can divide the top and bottom by 60 to get that. And then we're going to get 12 squared is 144. You can divide 6 into itself once and into 144 24 times. 24 times 5 is 120 pi, and we have units here, it's square centimeters. 18. Find the area of a sector. It's theta divided by 360 degrees times pi r squared. Our theta in this case is 90. Our radius is 2. 90 over 360 is 1/4. 2 squared is 4. A fourth of 4 is 1. The unis are square centimeters. So the area is pi square centimeters. All right, we're getting closer. Determine the area of the following figures, lines that appear to be yada, yada, yada. Now check this out. If I took this semicircle and paired it with this semicircle, I'd find myself with a complete circle. If I took this semicircle and paired it with this semicircle, I'd find myself with a complete circle. Those two circles are the same length because they have the same diameters. So to find the area of this figure, I'm going to take the area of this rectangle and add it to 2 times the areas of one of these circles, because they're the same. Area of a rectangle is base times height. 2 times the area of a circle is 2 times pi r squared. This rectangle has dimensions of 6 by 6 because this is 6 and each of these are 1 dash, so they're all 6. So the rectangle is 36 square centimeters, and the radius, the diameter of the circle is 6, the radius is half of that, so that's 3. So that's 2 times pi times 9. I get 36 plus 18 pi, and the units are square centimeters. 20. To find the area of this figure, I'm going to do, see, we got this triangle and this triangle are the same, and then we have a semicircle. So the area of this teardrop looking figure is going to be 2 times the area of one of those triangles plus the area of the semicircle. Area of a circle is, area of a triangle is 1/2 base times height. Area of a semicircle is half pi r squared. Please note, 2 times a half cancels, so it's just the base times the height. This triangle is a 45, 45, 90, so that means it's isosceles, so the base and the height are both 4. That makes the radius of this 4. So I'm going to get 16 plus half pi times 16. That's going to give me 16 plus 8 pi, and the unis are square centimeters. 21. Boy, it just never ends. Just never ends. We got a semicircle. We got a triangle, and we got a rectangle. And this is 4 because they're parallel to parallelogram. So that makes the radius here 2 because 2 and 2 is 4. To find the area of this figure, I'm going to take the area of the semicircle plus the area of the triangle plus the area of the rectangle. Area of a semicircle is half pi r squared. Area of the triangle is half base sub 1 times height sub 1. And the area of a rectangle is, I said height sub 1, and then I wrote the 2. Area of a rectangle is base sub 2 times height sub 2. So for the semicircle, the radius is 2. That's 2 squared. It's going to be half pi times 4. That's going to be 2 pi is the area of the semicircle. The triangle is half of 4 times 4. That's going to be 16 times a half. That's 8. The rectangle is 3 by 4, or 4 by 3, whichever you prefer. 8 and 12 is 20. Area of this figure is 2 pi plus 20 square centimeters. 22. Regular figures. These are the ones that are potentially the most work. Find the area of each regular polygon. Pentagon with an apothem of 4 centimeters. So it tells us it's regular, so I'm going to draw a regular pentagon. We know the apothem is 4. We need to figure out what the perimeter is. To do that, we need to find the length of the side. To do that, we need to find a central angle. Central angle is 360 divided by the number of sides. Pentagon has 5 sides. The central angle is 72. An apothem and a radius come together to make half a central angle. That makes this 36 degrees. To figure out the length of this side here, which we'll call x, I'm going to use trig. Tangent of 36 degrees is the opposite leg over the adjacent leg. You multiply both sides by 4. You throw that in your calculator. going to get that is about 2.91, which means this side over here is also 2.91 because an apothem always bisects that side. That means the length of a side is 5.82. We did that second. Let's find the perimeter, which is the length of a side times the number of sides. The length of a side is 5.82. The number of sides is 5. That's going to give us a perimeter of 29.1. And then finally, to find the area of a regular figure, it's half the perimeter times the apothem. Perimeter we said was 29.1. The apothem is 4. That's going to give us 58.2 square centimeters. That problem was exhausting. Number 23, equilateral triangle with sides of length 6. Equiangular, equilateral. If you draw the height, it cuts the angle in half. Half of 60 is 30. Also, is an altitude, and it cuts the side in half, which makes each of these 3. This is a special right triangle, 30, 60, 90. Short leg is 3. The long leg is the short leg times the square root of 3. That makes that 3 square roots of 3. So the area of a triangle is 1/2 the base times the height. The base is 6. All the bases are 6 in this. And the height is 3 square roots of 3. That's going to give us 9 square roots of 3 square centimeters. 24. Hexagon with a perimeter of 48. Well, let's draw this hexagon. Didn't end up too nice. It's better. So if the perimeter, which is length times the number of sides, is 48, and this has 6 sides, that's going to make each side 8. Excuse me. That's relevant because we want to try to figure out what the apothem is. We want to also find a central angle. Central angle is 360 divided by the number of sides. This has 6 sides, so that's 60 degrees. So if that's 60, a radius and an apothem always cuts that central angle in half, which makes it 30, which makes this a 30, 60, 90. And if this whole length is 8 and it's being cut in half, each of these halves have to be 4. And a 30, 60, 90, the long leg is the short leg times the square root of 3. So that is what the apothem is. Area of a regular figure is 1/2 the perimeter times the apothem. The perimeter, we were told at the beginning, is 48. The apothem we just discovered is 4 square roots of 3. So that's going to be 96 square roots of 3 square centimeters. Hopefully the problems I did here made sense and you understand this well for your chapter test.